We've spent the last couple of lessons talking about adding and subtracting rational expressions, which I think is one of the more difficult things you have to do with rational expressions. So today we're going to talk about multiplying rational expressions. Now, before we talk about rational expressions, we're going to talk about rational numbers or fractions. So some things to remember when we multiply rational numbers is that we have to consider any factors in the numerator and denominator. So if you can factor the numerator or denominator, you do that. If there are common factors in the numerator or denominator, you reduce them by dividing out, and then you multiply the numerators and denominators together. So we're going to start by doing a couple examples using just numbers, and then we're going to go ahead and we're going to do some rational expressions. So in this first example, if we look, there is nothing we can do to simplify any of these fractions. So what you do is you multiply the numerators and denominators together. 7 times 1 is 7, and 5 times 10 is 50. That's about as simple as it gets. Nothing to simplify, you just go ahead and multiply everything out and you're basically finished. If you look at the second example, let's look at the 9 and the 6 first of all. They both divide by 3. So 9 divided by 3 is 3, and 6 divided by 3 is 2. 5 divides into 10. It divides into itself once, and it divides into 10 twice. So we're left with 3 times 1, which is 3 in the numerator, 2 times 2, which is 4 in the denominator, and there we have our final solution. Now, something you're going to notice is that life is going to get really messy when we start simplifying and dividing out common factors and things of that nature. So it's really important that you're writing clearly on your paper, or you're going to get mixed up with what's multiplied together and what you've simplified and everything like that. The other thing you need to remember is that to be able to simplify terms, one of the terms has to be in the numerator and the other term has to be in the denominator. You cannot simplify two terms that are both in the numerator or both in the denominator. The other thing you need to remember is that when you state restrictions in a rational expression, you state the restrictions before you do any simplification at all. So we're going to do a couple of things. We're going to start with monomials, single-termed expressions, and simplify them. Then we're going to move to binomials and trinomials. So we're going to gradually move from simple to more difficult. For some people, you are going to have to just watch the example, then write it down, then maybe even re-watch the example to help figure out what are we simplifying, what are we dividing out, how did we come to our final solution. So if we look first of all at this first example of monomials here, when we do restrictions, we look at the variables that are in the denominator. And in this case, we know that z cannot equal 0 and y cannot equal 0, because that would make our denominator 0, and we can't have that because we'd have division by 0. Now, I'm going to try to use in this lesson some colors and some pens to help illustrate all the things that we're simplifying. So hopefully by the use of color, you're going to be able to see the different parts that we're simplifying together. So first of all, I'm going to look at the 12 and the 4. Well, 4 divides into itself once, and it divides into 12 3 times. Next thing I'm going to look at is I'm going to look at these y's here. I have a y in the numerator and a y in the denominator, so they divide out and they cancel themselves out. The third thing I'm going to look at is the z's here. This z, remember z squared is like saying z times z. Well, this one z cancels out one of the z's in the numerator, so you're left with a single z. So if I look at what's left in the numerator, I have 3x times 3xz. So some people like to write that out. I've got 3x over 1 times 3xz over 1. So if I now multiply this out, well, 3 times 3 is 9. X times x is x squared, and I also have a z, so there is my final solution. So sometimes it helps to write out what you have in your two fractions before you go ahead and multiply them out. Hopefully the use of color is helping illustrate what I canceled out with what. Okay, the next question's a little more complicated. First thing we're going to do is state our restrictions. And if we look at the denominator, we have A's, B's, C's, and D's. Well, A, B, C, and D cannot be equal to 0 in this particular situation. Now, I'm going to start simplifying things. I'm going to look at 5. Well, 5 goes into itself once, and it goes into 40 8 times. I'm going to look at the 35 and the 14. Well, 7 divides into each of those. 7 divides into 14 twice, and it divides into 35 5 times. Now I'm going to start looking at each of these fractions here. If I look at this second fraction, there's nothing about the variables that I can simplify in the numerator and denominator. This has a b, and that has an a cubed and a c, so there's nothing that can simplify there. If I go back to this first fraction, I have a b squared in the numerator and a b squared in the denominator. Doesn't look like, oh, this c can eliminate one of those c's, so I'm left with c cubed. If I now look across, a squared cancels out 2 of these a's here, so I'm left with just a. C cubed and c, well, this c cancels out one of those c's, and I'm left with c squared. So what have I got left in the numerator here? I've got 1c squared divided by 2d, and here I have 5b over 8a. So now, if I start multiplying things out here, 5 times 1 is 5. We do things alphabetically, so the b's will go next, and the c's will go third. 8 times 2 is 16. A times d is just AD. Now, once you've multiplied this out, you then have to look at this and see, is there anything else I can simplify? Because sometimes you're going to realize there will be variables or there will be values that you can simplify here. So you do have to check that out. In this case, there's nothing else to simplify, so there is our solution. Okay, so the most confusing part to most people is all the simplifying and all the canceling that's going on here. If you can't do this all at once, you may have to rewrite your fractions multiple times to help you cancel out things. All right, let's look at the next situation where we've got some binomials that are occurring here. First thing you always want to look at is you want to look at, can you factor either the numerator or the denominator? In this first example, everything's factored, so we don't have to do anything there. Then we have to state our restrictions. Well, x cannot be positive 2, negative 3. Remember, when there's a single x, that means x cannot be 0, and x cannot be negative 1. So there are 4 values we cannot have there. So now I'm going to use my colored pens, and I'm going to start dividing things out. X plus 1 divides out x plus 1. X plus 3 divides out x plus 3. So if I look at my numerators, all that's left in the numerator is a 2. If I look at my denominators, I've got x times x minus 2 left in the denominator. Cannot simplify this 2 with that 2 because this is a binomial, and you need to be able to simplify or divide out the entire binomial in this case. So that's where we stop. Okay, second example, remember the first thing we do is we look at trying to factor anything that we can. So if we look at our first numerator, we can take out a common factor of 4. And if we look at our first denominator, we can take out a common factor of 7. Nothing I can do to my numerator on the right side. X plus 4 squared means x plus 4 times x plus 4. So I'm going to write both of those factors out so that if I'm going to eliminate them, I can. So now I start looking at things. Oh, I have a 2x minus 1 in the denominator and 1 in the numerator. Those can simplify. I have an x plus 4 in the numerator here, and I have an x plus 4 in the denominator here. So if I now look at this, 4 is all I have left in the numerator, and I have 7 times x plus 4 in the denominator. So there is our rational expression in simplest form. All right, we're going to look at a couple more examples. Basically, all we have to do in the rest of these examples is factor and eliminate or divide out common terms. So if we look at the numerators and the denominators in this next particular situation, the numerator in the first fraction, I can take out a common factor of 2m squared, and that leaves you with m minus 2. In my denominator, I can take out a 3m, and I'm left with m minus 3. If I factor my numerator, remember, anytime you have to use box method, you can do that on a scrap piece of paper and then write down your two binomial factors that you get. So our two factors are going to be m minus 3 and m plus 2. Our denominator is a difference of squares, so when we factor that, we get m minus 2 and m plus 2. So I think you're starting to see why factoring is so important in this course. 2 units ago, we did a whole unit just on factoring. In the previous unit on quadratic functions, you still had to factor to solve equations, to find x-intercepts, etc. And now in this third unit, you continue to have to factor. So factoring is a hugely important thing in 20-1. Okay, so now I'm going to state the restrictions before I go on. What can m not equal? Well, 3m here, if you equate it to 0 and solve it, it says m cannot be 0. M cannot be positive 3, m cannot be positive 2, and m cannot be negative 2. There are our restrictions. So now we're going to start simplifying things. If I look on the far right side, I have an m plus 2 in the numerator and an m plus 2 in the denominator, so I simplify those. Here I have an m minus 3 in the numerator and an m minus 3 in the denominator. Here I have an m minus 2 in the numerator and an m minus 2 in the denominator. So now I'm down to 2m squared over 3m. That's all I'm left with. Now some of you might think you're done at this point, but you aren't. We cannot simplify the 2 and the 3, but m goes into m squared. It cancels out one of those m's. So you're left with 2m over 3 as your final solution to this problem. And again, our restrictions are over here. Okay, last example coming up. For the most part, we're going to do a lot of factoring on a scrap piece of paper with this. We have to use box method to factor this. When we factor our numerator, we're going to get a plus 5 and a plus 3. Let's look at this numerator. I can take out an a, and I'm left with 1 minus 4a squared. If I now look at factoring here, let's see what we're going to get. We're going to get 2a plus 1. Oh, hold on, hold the phone. We can actually take out a common factor in this denominator before we get started. We can actually take out a common factor of 3 from all of these terms. So that leaves me with 2a squared plus 7a plus 3. And nothing I can do to take out a common factor there, but if I factor that, I get 2a minus 1 and a plus 5. Now I need to go back because I can factor some more here. I still have a plus 5 and a plus 3 in my numerator. I have a common factor of 3, and if I factor this denominator, I end up with 2a plus 1 and a plus 3. Remember, I'm doing box method on a scrap piece of paper to come up with these particular factors. Here I have a difference of squares. This is going to be 1 minus 2a and 1 plus 2a. And I have 2a minus 1 and a plus 5. So now I have actually figured out all of my factors for all of these things. So now I can state my restrictions. What can a not be equal to? Well, a cannot be equal to negative a half, to negative 3, to positive a half, and to negative 5. So there's our restrictions. Now I'm going to start simplifying things. In our fraction on the left side, I have a plus 3 in the numerator, a plus 3 in the denominator. I have an a plus 5 in the numerator on the left side and an a plus 5 in the denominator on the right side. I have a 2a plus 1 here and a 1 plus 2a there. So that all cancels out. Now, let's see. In the numerator here, I'm left with 1 in the numerator over 3 in the denominator. My numerator here is a, and this is 1 minus 2a and 2a minus 1. Now if you look at these two factors here, they're the exact opposite of each other. 1 minus 2a, the 1 here is positive, the 1 is negative there. The 2a is negative there and the 2a is positive there. When you have factors that are exact opposite of each other, they divide into each other negative 1 times. So I have 1 times negative 1, which is negative 1, and I also have an a in the numerator. I have a 3 in the denominator, so there is our answer in simplest form. So that's about the most complicated kind of question you're going to get today, where you've got a ton of factoring you need to do first on a sheet of scrap paper, and then you need to do all of your simplifying to finish off the question.